This is question 13 in chapter 10 of our physics textbook. And question 13 asks, if we have an 80 kilogram man, how fast would he have to be running in order to have the same kinetic energy as an 8-gram bullet that's traveling 400 meters per second? So to do this problem, we need to first write down the information that we have. So we know the mass of the bullet is 8 grams, but in order to cancel units later, we need to convert it to kilograms. So we get 0.008 kilograms for the mass of the bullet, and then for the velocity of the bullet, it gives us that. It says it's 400 meters per second, and the mass of the person is 80 kilograms. Now once we have all this information, all we need to do is use this formula for kinetic energy, which says kinetic energy equals 1/2 the mass times velocity squared. And so we can do it for the bullet since we're provided both the mass and the velocity. So if we do it for the bullet, like here, we have our kinetic energy for the bullet equals 1/2 times the mass of the bullet, which is 0.008 kilograms, times by the velocity, which is 400 meters per second, and then squared. And once we do that calculation, you'll get the kinetic energy of a bullet is 640 joules, because the units for joules is kilograms times meters squared divided by seconds squared. So once we have this, the kinetic energy for the bullet, we can now solve for the kinetic energy of the man, because in the problem it says we want to find the speed at which they have the same kinetic energy. So we know what we want in our problem is that our kinetic energy for the bullet equals the kinetic energy of the person. So we can solve for the speed of, like, the person would have to be traveling in order to have the same kinetic energy by using this same formula here, but by rearranging it to where we're solving for velocity instead of for the kinetic energy. And then we just need to input the kinetic energy for a bullet in place of the kinetic energy for the person, because they should be the same at the end. So what we end up getting is this equation here. The velocity of the person equals the square root of 2 times the kinetic energy of the bullet divided by the mass of the person. And so if we input the information we have, we get square root of 2 times the kinetic energy, which is 640 joules, divided by the mass, which was 80 kilograms. And once we enter this into our calculator and solve, we should get the velocity of the person equals 4 meters per second. And that's the answer to this question. And the reason we get meters per second is the kilograms. We'll cancel out the kilograms from the joules, and the square root will make it so it's just meters per second. And that's how we get our 4 meters per second, which is the answer to question 13 in chapter 10.